Okay, this little demonstration is to show how PORPIS proposes that the larger planets, Jupiter, Saturn, and Uranus, and Neptune, but mainly Jupiter and Saturn, are what cause not only the solar cycle, but the parts of the solar cycle, which make it the solar cycle. Not only the flipping of the poles of the sun, which I'll show later more how this could happen, but what I want to talk about is the sunspots and the solar flares that happen between the spots or among the spots or within the sunspots, and the prominences that come along with that cycle, the heavier cycle of the solar cycle. What I have here is just a spring. It's kind of a bunch of springs connected, and it doesn't matter which way it's wound, but the planets are connected to the sun by magnetic. So this would be like a magnetic connection between Jupiter and the sun, okay? And it's rotating, just like a magnetic field, just like I showed with my magnets. So it'll be north up, which would bring the north over towards the sun, which we're looking at a south. But that's not a big point at this right now. So the connections happen, and as they do, that connection moves with the rotation of the sun, which rotates past where the planets are. The sun's rotation supersedes the orbit of any planet. Not the rotation of the planets, but the orbits. So the sun is rotating quick. 30 days is all it takes for the sun to make a rotation, around 25 to 30 days. So as these connections are there, they lay down. They don't stand. They get tugged along. So the magnetic field from the planet to the sun, it kind of lays down. And it'll be one on the north side, and then you've got another one reversed on the south side. But we'll look at the north, and you just reverse everything I do here on the north to the south. So as this is rotating and it lays down, those are your prominences, always from 55 degrees down towards the equator. Right in there on the north, and same on reverse on the south, or same on the south. What happens is that lays there, that causes your prominences, and it causes your sunspots, because this rotating magnetic field from these bigger planets, they will lay down and get wrapped around the sun as such. And then they'll snap and break, and then it'll make a new one, and then it goes around, and it'll snap, and another one. And that's what causes a lot of your fluctuations in electromagnetic radio bursts out of the sun throughout the cycle. But I want to show with another demonstration how this works, which you'll see in the videos of the sun, how this prominences just lay on top the plasma, and they're suspended because the magnetic fields are pushing and pulling, just like a smart magnet. It can only pull together so far, and the other repulsions keep it from coming all the way together, if you've ever seen smart magnets. But that's what keeps this prominence above. But once that magnetic field, once the snap happens between the planet and the sun, and it gets a new one, that rotation's still there, and it slams down into the plasma, and that's where you see your coils of plasma rotating with this, or getting pulled in and out of the sun with this rotation that's broke away, and it lasts a little while, then it dissipates or slams into the sun and gets broke up. That's what causes your sunspots too, is when this bows down into the plasma, you'll get a sunspot in the middle or at the end of this where it bows down into the plasma. I'm going to show all this in another demonstration along with some videos of the actual sun. So it's the big planets that's causing the solar cycle, and the big planets' connection to the sun are what cause sunspots, prominences, and solar flares, and which result in CMEs and so forth. So we'll move on and show you a little more. Let's suppose this is just a small section of the surface of the sun. That's why I've got it yellow. And this spring is going to represent a magnetic field coming from one of the planets towards the sun, Jupiter. Anytime it's laying across, you have what I'll call, it's a prominence across the top of the surface of the sun. But when it bows down into the surface, like so, that's when you get sunspots. And then when the whole prominence breaks, that's when you see this rolling and twisting and looping from sunspot to sunspot. And then when it snaps and lays down into the plasma, you see those loops in a whole thousands of miles long and huge, looping over, following that magnetic field coming from one of the larger planets. That's what it is. So anyway, I wanted to show that as the best I can. I'll give you sunspots when just a little bit of it bows in on each side. Let me turn it this way. Your sunspot will be on your left and your right. This side of the spring and that side of the spring, which would be the magnetic field, be a sunspot on either side. Then when the whole thing lays down and snaps, that's when you get your prominence disappears and comes up. The plasma comes up, but the magnetic field goes down into the plasma, and you get your looping coils all along that for thousands of miles. That's what PORPIS proposes happens.